Okay, this is 9.2, quadratic functions. Copy down the objective, which is to graph functions of the form y equals ax plus b, ax squared plus bx plus c, and then the essential understanding. In the quadratic function, y equals ax squared plus bx plus c. The value of b affects the position of the axis of symmetry. Line. If we were to fold our paper along that dotted line, the graph, the red part of the graph, would match up exactly with the other side. Do you guys see that? So this graph, right, this blue part matches up exactly with the green part, okay? Because they're symmetrical, right? So how do we find that axis of symmetry? There's a really easy way to figure out where your axis of symmetry is, okay? And it has to deal with using A, B, and C, okay? So our axis of symmetry, right? It's always going to be in the form x equals a number, x equals a number, x equals a number, okay? But how do we find that number, okay? And it's just going to deal with the ratio of B over A, okay? So what I want you guys to copy down on this part is the axis of symmetry is x equals -1/2 B over A, or x equals -B over 2A. Yeah, a little bit. So it's like the opposite. That was a good point, Roy. It's like the opposite of factoring. In factoring, well, we actually did A times C. Do you remember? Yeah. Remember, B is your second.
Yeah, opposite because you're not using C anyway.
Yeah, we're not using C right now. Okay. The function y equals x squared minus 6 plus 4. Go ahead and copy that down. Y equals x squared minus 6x plus 4, okay? And I want you, on your paper, I'm going to rewrite it. You don't have to rewrite it. You're just going to write it down one time. But we have to identify what our A is, what our B is, and what our C is. A is just going to be the number in front of the x squared, which in this case is 1. B is going to be the number in front of the x, which is -6. And C will be the number at the very end with no variable, so plus 4. Okay, so we've established that A is 1. B is -6, and C is positive 4. So, our axis of symmetry, write this down. There we go. Axis of symmetry is x equals -B over 2A. And let's just plug in what we know B is and what we know A is. In other words, negative. B is what? -6. And A? So plug in a 1 and plug in a -6 wherever you see a B, wherever you see an A. Okay, negative times -6. What am I going to get in the numerator? Anderson? Positive 6. What am I going to get in the denominator when I multiply 2 and 1? Dos. Does this fraction simplify? To what? 3 over 1, which is the same as just 3. So my axis of symmetry is x equals 3. So I need you guys to draw a graph because we're going to start graphing this, okay? X equals 3, okay? So my axis of symmetry, I'm going to find 3 on my x-axis, and I'm going to draw a dotted line all the way down. All the way down. That is my axis of symmetry. At x equals 3, I'm drawing a dotted line all the way down. Anderson?
Why is it a dotted line?
Why is it a dotted line? Because it's not part of our graph. Okay? It's not part of our graph. It's like just the axis of symmetry. So what's going to happen is we're going to see both sides of our actual graph being symmetrical about this line. Okay? It's like when we actually graph it, we don't need to have the axis of symmetry. Okay? It's dotted because it's like it's not part of our graph.
Okay.
Good question. Okay? All right. So we did our dotted line. Now look what happens. We're going to find our vertex by plugging in this 3 into our original equation. Okay? So take x equals 3 and plug it in to our original equation, which was y equals x squared minus 6x plus 4. Y equals x squared minus 6x plus 4. So wherever I see an x, I'm plugging in 3. So y equals 3 squared minus 6 times 3 plus 4. Y equals 9 minus 18 plus 4. Because 3 times 3 is 9, 6 times 3 is 18, and 4 just stays as 4. So we're going to get y equals 9 minus 18 will give me negative 9 plus 4, which will give me negative 5. So what I have to do is I have to go, okay, I know it's going to lie on this axis of symmetry, go down 5 units, and put a point. So my vertex is at 3, negative 5, okay? Your vertex will always lie on that axis of symmetry. Okay, the last thing we're going to do, okay, is we're going to finally use our C, because we haven't used C yet, right? What C is that is your y-axis. So, Y-intercept. So C was 4, right? All I do is I go, okay, where's 4 on the y-axis? Oh, it's right here. Put a point, and we're done. All we have to do is create our graph based on this. So if our axis of symmetry is here, here's my curve, and then I just do the same curve on the other side. Alan.
Is that like an easy way to find your answer?
Is what?
Is that like an easy way to find your answer?
Yes. So, if you could not remember this on the test, what did I tell you to do? Plug and chug, okay? You would just plug in values of x and you would output values of y. Okay? We're going to pick up. Oh, goodness. Here we go. x squared minus 4x plus 1. First thing that we need to do is identify what's A, what's B, and what's C. In this one, Giancarlo, what's A?
X squared.
It's not x squared, it's the number in front of x squared.
1.
Uno. What's B, Roy? -4. And what's C, Alan? 1. Okay? So we identified A, B, and C. Remember, your axis of symmetry you're going to have to memorize this, is x equals -b over 2a. Always and forever, okay? -b over 2a. You're going to have to memorize that, okay? All right, so all we're going to do is plug in what we know for b and what we know for a. So x equals negative. Remember, whenever we plug in, we put parentheses over 2 times a. What was b? -4. What was a? 1. Now we just solve it. X equals, what's -4? +4. And what's 2 times 1? 2. What's 4 divided by 2, Nicole? Just 2. So our equation is x equals +2. All we have to do is on our x-axis, find 2 and draw a dotted line vertically, okay? So on our x-axis, that's on our horizontal axis, find where 2 is and draw a vertical dotted line. Who remembers from yesterday, why is this a dotted line and not a solid line? Roy?
It's not part of our, like,
Correct. It's not actually part of our graph. It's just the axis of symmetry. So it shows us that each side of that line is going to be the same for our actual graph. It's just kind of like a reference point, okay? That's why it's a dotted line and not solid. Okay. Now, from here, we used A, we used B. Which one haven't we used? C. So what we do with C is we just say, okay, C is our Y-intercept. So C is where our graph crosses the Y-axis. So all we're going to do is take that 1, find it on the Y-axis, and put a dot. So I'm putting a dot at 1, because our C was 1, on the Y-axis. Okay? And then the last thing that we do is we take the 2 that we found over here and we plug it into our original equation. So our original equation was y equals x squared minus 4x plus 1. Wherever I see an x, I'm plugging in a 2. So y equals something squared minus 4 times something plus 1. And that something is just this 2. Two squared and 4 times 2. All right, peeps. What is 2 squared? 4. So y equals 4 minus, what's 4 times 2? 8. And then we just add 1. What's 4 minus 8 plus 1? Y equals negative 4 plus 1, which is negative 3. So look what happens, okay? Our x was 2, our y is negative 3. So 2 comma negative 3. That is our vertex, and it's going to lie on the axis of symmetry. So let's find that point, 2 comma negative 3. 2 comma negative 3 is right here. It should be on our axis of symmetry, which it is, and this is our vertex. So our graph, we're just going to connect these 2 dots and do the same thing on the other side. That's creepy. The wind is like howling. You don't hear it? I heard it. Okay. Any questions? This one, okay? I want to look at y equals negative 2x squared minus 8 minus 3. All right, check it out, check it out. So we got to identify A, B, and C. Nicole, what's A going to be? What's that? Negative 2. Maya, what's B going to be? Negative 8. Just negative 8. Remember, just the number part. And Janessa, the C? Negative 3. I love how each and every one of you said negative, okay? That is super important. Always account for the sign in front of the number, okay? So A is negative 2, B is negative 8, and C is negative 3. Who has already memorized the axis of symmetry? What's the formula? Maya?
X equals negative B over 2A.
Booyah! We got it. All right? Find a way to memorize that. X equals negative B over 2A. Janessa, let's plug that in. X equals negative. We're plugging in for B, so put parentheses. We're plugging in for A, so put parentheses. What goes in for B, Janessa? Negative 8. What goes in for A? Negative 2. Let's simplify this. Victoria, you're up. Mm-hmm. And then Elijah, help me out. How can I simplify 8 over negative 4? Uh-huh. So this would actually be 4 over what? Negative 2. Does that simplify even more?
Yeah.
To what?
Just 1.
You're close.
2 over negative 1.
2 over negative 1, which is just negative 2. You can think about it as 4 divided by negative 2, right? A positive divided by a negative is just going to give me a negative number, and 4 divided by 2 is just 2. So we've got our formula, x equals negative 2. I said formula, I meant equation, okay? So what do I do with that? Ashton. Okay, eventually. But what should I do before I do that? Tessa? Plot it. How do I plot this?
Okay, so since you're gonna go negative 2 and you're gonna draw that line going all the way down.
Ah, right here, right?
Yeah.
Excellent. So we've got our axis of symmetry at x equals negative 2. All right, so I used A, I used B. What do I do next? Tessa?
You're gonna plot it.
Plot what?
So if your x, it's gonna be negative 2, right?
Okay.
That's right. And the original equation.
But before we do anything else, remember what I said. We used A, we used B. Nicole, what do I do next? C. What do I do with the C? Does anyone remember? Roy?
You're gonna, plot, so like, as your Y-intercept.
Very good. This is my y-intercept. So I find my y-axis, which is my vertical one, okay? And I'm going to find the point at -3. Go all the way down to -3 and just put a dot. So I'm going to put a dot right here. You guys with me? Okay. Now, from here, I know one of my points. I just need to find my vertex, and I'm good, okay? So let's find my vertex. How do I find my vertex? Alan?
You plug the x into your equation.
Very good. I take this x equals -2, and I plug it back into the original. So I've got y equals -2 something squared minus 8 something minus 3. What am I plugging in for x? Tessa? -2. Now comes the part where we have to be very careful with our negatives. Nicole, you want to give it a shot?
Okay, but after he is about them.
Yes.
Is it y equals,
Let's take it one step at a time.
-8?
Ooh, good. But let's do -2 times, what's -2 times -2? +4 inside the parentheses. You're right, it is eventually -8. And then this second term turns into what?
16.
Why +16?
Because -8
Good. And then what? Excellent. Now you can go to the bathroom, okay? Janessa, help me. Finish it off. Rayoni, can you help me out with this last part? What's -8 plus 16 minus 3? Close.
5.
Yes. +5. Did you get that same thing, Ashton? Beautiful. Okay. So my point of my vertex is something, comma, something. Use my x value, which is -2. Use my y value, which was 5. So at -2, 5, which should be a point on the axis of symmetry, I'm putting a point, and I'm creating my graph. Whoa, 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 whoa. Hold on. My vertex is now the highest point. Uh-oh. Did I mess up? Why not? But what changed between these two equations? What was super different? Tessa?
Mostly because there's more negatives.
Yes. No, not more negatives. The only one that matters is A. Do you see how in the first one, A is positive? In the second one, A is negative. My graph is going to face downwards. So when I draw my graph, it's going to look like this, and it's going to look like this. Do you guys see that? Uh-oh. Alan's shaking his head no.
No.
Why not?
I thought it's supposed to go like this.
It normally is, right? It's supposed to go like this, right? Open upwards. But when your A is negative, check this out. A is -2, right? You have to flip it. It's going to face downwards, okay? Now, if you were to look at this and be like, oh, it has to face upwards, well, I'm going to do this in a different color. It's going to look like this, right? I didn't even, that will not be symmetrical over the red line, right? The red axis of symmetry is to show you, okay, I have the same thing on the left side as I do on the right. If I do this with the green, that is not going to look good, right? That's definitely not symmetrical over the red line. So that was another way you could figure out it's not right, okay? And if you still are like, I have no idea what's going on, the method that will always work and never fail is plug and chug. Just pick values for x, start plugging them in, and then you'll figure out what your graph needs to look like. Okay? All right, questions so far? Alan, did that help?
Yeah.
All right. We got 2 more, people, and then we're done. Y equals 3x squared plus 6x plus 2. Okay, peeps. What is my A? Rioni?
6.
Nope. Close. Yep, it's the 3, okay? Your A is always your first, the number in front of the x squared. Ashton, what's my B?
6.
Positive or negative? And Victoria, what's my C?
2.
Positive 2. Okay, so we've got A, we've got B, we've got C. Who's memorized the axis of symmetry? Give it to me, Carlos.
It's y equals negative b over 2a.
Excellent. Let's go. X equals negative B over 2A. We're going to plug in what we know. So X equals negative parentheses over 2 parentheses. Because we're plugging in for B and we're plugging in for A. What do I plug in for B? Roy?
The 6.
The 6. What do I plug in for A?
The 3.
The 3. Alan, what is this going to be? Which is? Negative 1. So X equals negative 1 is my axis of symmetry. How do I graph that?
The dotted line.
Dotted line where?
On the negative one.
On this negative 1? So like this? No? Why not?
Because it's your x.
It has to be on my x-axis. Okay. So what do?
Put it on the negative one on the x.
Good. Put it on my negative 1 on my x-axis. Because it's x equals negative 1. What would be the graph of that horizontal line I drew? What would be the equation for it?
X equals 70.
Let me draw it again. What would be the equation for this line? If this one in red is x equals negative 1, what would be the equation for the blue one? Y equals negative 1. Okay? But we're going to ignore that for now, because that's not what we're doing. So we plotted my axis of symmetry. Who remembers what I do next? Tessa?
Okay, so don't you plot your C?
A, there we go. Don't forget about the C, people. So where do I plot my C? On my y-axis, okay? So let's go up my y-axis to 2 and put a dot. I'm going to put C equals 2 here so we remember where that came from, okay? And then my last part, what am I doing? Plugging back in. So let's plug in x equals negative 1 to our original expression. So we've got y equals 3 times x squared plus 6 times x plus 2. Wherever I had an x, now I'm going to have what?
Negative 1.
Negative 1. And let's solve this. Y equals 3 times what? 1 plus negative 6 plus 2. Because remember, 6 times negative 1 is going to give me a negative value, right? So y equals, what's 3 times 1? 3. What's, and then we're just going to make this minus 6 and then plus 2.
Negative 4.
Yes. No.
Negative 1.
Negative 1. y equals negative 1. Because 3 minus 6 is negative 3, right? You add 2 to that, and you get minus 1. This is the same as negative 3 plus 2, which is then y equals negative 1. Okay, so my point is negative 1 comma negative 1. That's my vertex. Let's see if it matches on our axis of symmetry. And it does. Negative 1 is right here. That's on my axis of symmetry. So that's my vertex now. So I'm just going to draw my arcs. There's the same point on this side of the axis of symmetry. And we're done. How did I know before I started this problem that my graph was going to be upright? It was going to look like a valley. Carlos?
Because your x is positive and your n is positive.
Very good. Because my A is positive, I knew that I was going to have a minimum and my vertex was going to be at the bottom of my graph. Okay? My graph was going to face upwards. If my A is negative, what's going to happen? It's going to flip it. Okay? My graph is going to point downwards. All right, let's do one last example. If you are like, I got this, I understood everything this man has said because he's such a great teacher, do it on your own, okay? If you're still like, maybe I could see one more example, I'm not 100% sure, then just follow along, okay? All right, so for this last example, don't freak out because this has f of x. You just treat it just like y, okay? So f of x equals negative x squared plus 2x minus 5. First things first, guys, we identify the A, we identify the B, we identify the C. Our A is negative 1, our B is positive 2, and our C is negative 5. From here, we write our axis of symmetry, which is x equals negative b over 2a. And we're just plugging in here, okay? So wherever I see a b, I'm going to put parentheses. Wherever I see an a, I'm going to put parentheses. And now our b value is 2, so I put a 2 up here. And our a value is negative 1, so I put a negative 1 here. So in the end, we've got negative 2 over negative 2, which is positive 1. So I know x equals positive 1 is my axis of symmetry. So what I'm going to do here is I'm going to take that and I'm going to plot it. In other words, I'm going to go at positive 1. I'm going to draw a dotted line all the way down my graph. Perfect. Okay, once I've done that, I've used A, I've used B. I haven't touched C yet, so we gotta use C. Remember, everyone gets used, okay? You've got to use every little piece of information. So once I pull C, I find a negative 5 on the y-axis, and I just put a dot. Okay, so I found a point on my graph, but I still don't know where my vertex is, okay? So in order to find my vertex, I just take the x equals 1, and I plug that into my original equation, okay? Because I'm going to find where my graph is going to cross the axis of symmetry. So y equals negative, put parentheses, we're going to square that x value, plus 2, put my parentheses, minus 5. Wherever I see a parentheses, I'm plugging in 1 for x. So I've got y equals negative, 1 squared is just 1, plus 2 times 1, which is 2, minus 5. So y equals negative 1 plus 2 minus 5. Y equals negative 1 plus 2 is just positive 1 minus 5, and I get negative 4. So the point on my graph, that is my vertex, is the point 1, comma, negative 4. In other words, on my axis of symmetry, my y value should be negative 4. So I go down to negative 4, and I put a point right here. Now, this looks like, since this is my vertex always lies on my axis of symmetry, it's going to be a downward looking graph. Just by looking at the original equation, how did I know that my graph was going to point down? Nicole? Very good. My A was a negative number. My A was negative 1.